Good morning and happy Pi Day. Well, technically it was yesterday, but obviously that was a Sunday. So today we will be celebrating Pi Day in your PSHE lesson, and it's going to be a recurring theme in your mathematics classes. And there's a couple of competitions coming up which will challenge you to win house points added on to the ones that you've been accumulating in the other competitions. So give them a try. They'll all be done within the context of your maths classes and judged by Mr. Vitali. So enjoy them and have fun. So the videos I'm going to show you are all associated with Pi Day. Some of them are just giving you a bit of history and background to Pi Day. There's a song. Some of them are a little bit silly, but there's also some really serious points to be made about this really important day in the world of mathematics. So enjoy.
And now, ASAP Science presents 100 digits of pi.
3.14159, this is pi, followed by 2653589, circumference over diameter 79, then 323, OMG, can't you see? 8462643, and now we're on a spree. 38 and 32, now we're blue, oh who knew? 7,950 and then a 2. 88 and 41, so much fun, now a run. 9716939 and 3751. Halfway done. 458, now don't be late. 209, where's the wine? 74, it's on the floor. Then 94459. 230, we gotta go. 78, we can't wait. 1640628, we're almost near the end, keep going. 62, we're getting through. 089, 9 on time. 8628034, there's only a few more. 82, then 53. 42, 11, 70, and 67. We're done. Was that fun? Learning random digits so that you can write to your friends.
Try to measure a circle. The diameter and radius are easy. They're just straight lines you can measure with a ruler. But to get the circumference, you'd need measuring tape or a piece of string, unless there was a better way. Now, it's obvious that a circle's circumference would get smaller or larger along with its diameter. But the relationship goes further than that. In fact, the ratio between the two, the circumference divided by the diameter, will always be the same number, no matter how big or small the circle gets. Historians aren't sure when or how this number was first discovered, but it's been known in some form for almost 4,000 years. Estimates of it appear in the works of ancient Greek, Babylonian, Chinese, and Indian mathematicians, and it's even believed to have been used in building the Egyptian pyramids. Mathematicians estimated it by inscribing polygons in circles, and by the year 1400, it had been calculated to as far as 10 decimal places. So when did they finally figure out the exact value instead of just estimating? Actually, never. You see, the ratio of a circle's circumference to its diameter is what's known as an irrational number, one that can never be expressed as a ratio of two whole numbers. You can come close, but no matter how precise the fraction is, it will always be just a tiny bit off. So to write it out in its decimal form, you'd have an ongoing series of digits starting with 3.14159 and continuing forever. That's why, instead of trying to write out an infinite number of digits every time, we just refer to it using the Greek letter pi. Nowadays, we test the speed of computers by having them calculate pi, and quantum computers have been able to calculate it up to 2 quadrillion digits. People even compete to see how many digits they can memorize, and have set records for remembering over 67,000 of them. But for most scientific uses, you only need the first 40 or so. And what are these scientific uses? Well, just about any calculations involving circles, from the volume of a can of soda to the orbits of satellites. And it's not just circles either. Because it's also useful in studying curves, pi helps us understand periodic or oscillating systems like clocks, electromagnetic waves, and even music. In statistics, pi is used in the equation to calculate the area under a normal distribution curve, which comes in handy for figuring out distributions of standardized test scores, financial models, or margins of error in scientific results. As if that weren't enough, pi is used in particle physics experiments, such as those using the Large Hadron Collider, not only due to its round shape, but more subtly, because of the orbits in which tiny particles move. Scientists have even used pi to prove the elusive notion that light functions as both a particle and an electromagnetic wave, and perhaps most impressively, to calculate the density of our entire universe, which, by the way, still has infinitely less stuff in it than the total number of digits in pi.
Pi. What is pi? Well, pretty much all of us know that pi is approximately 3.14, but that doesn't really tell us much about pi. What is pi? How did it get its name? Who discovered it? And how did they approximate it? Well, that's a lot to explain. So I've challenged myself to cover all of these bases in 3 minutes and 14 seconds. So without further ado, I present to you the complete history and complete explanation of pi in 3 minutes and 14 seconds. Somewhat. Here we go. Pi. Not the kind you eat, but the kind you plug into your calculator to solve equations involving circles, spheres, and various other shapes. Most commonly approximated as 3.14 or 22/7, pi is an irrational number that is usually represented by the Greek symbol pi. Yes, the symbol as well as the number is referred to as pi. An irrational number, in case you didn't know, is a number with decimal places that spiral on infinitely with no discernible pattern. For a more formal definition of pi, let us look to the most forbidden of research sources, Wikipedia. Pi is commonly defined as the ratio of a circle's circumference to its diameter. Okay, look at this circle here. Are you looking at it? Look at it. Are you looking at it now? Okay, good. The diameter of this circle, which is, as you probably know, the distance from one side of a circle to a point on the direct opposite side, is 23. And the circumference, which is the distance around the entire circle, is about 72.25. If you divide the circumference by the diameter, you're going to get 3.14. This applies to all circles. If you get a tape measure and measure the diameter and the circumference of a circle, the ratio of the diameter to the circumference will always be pi, or approximately 3.14. Let's talk a little bit about the history of pi. Well, let's start with the most basic of questions, which is why did they name this somewhat aberrant number after a baked dish, which is usually made of a pastry dough casing that covers or completely contains a filling of very sweet or savory ingredients? I will answer your question now. The symbol of pi is actually a letter in the Greek alphabet. In both English and Greek, this letter, and therefore the number pi represents, is pronounced simply as pi. Popularizing this notation of pi is a man from the past who published a book in 1736 in which he referred to the ratio of the circle's diameter to its circumference as the Greek letter pi. This man's name was Leonhard Euler. Yes, I know it looks like Euler, but it's pronounced as Euler. You might have heard of him. He didn't have a ton to do with the actual discovery of pi, but he's still a pretty cool guy. This leads me to my next point. Who discovered pi? There's still a lot of debate about this. Some believe it to have been first approximated by the Egyptians because the construction of their pyramids leaves evidence of the architect's possible knowledge of pi. Others say no, it was the Babylonians in the 19th century BC. Gosh! So let's skip forward a bit in history where things get a little bit clearer. The first recorded algorithm for rigorously calculating the value of pi was created by a man named Archimedes. Archimedes? Archimedes? So Archimedes devised a method of calculating pi by using regular polygons that were circumscribed and inscribed within and around a circle. An inscribed shape is a shape that is drawn within another shape without flexing or changing its dimensions. A circumscribed shape is a shape that's drawn around another shape without bending or flexing its dimensions. Archimedes computed upper and lower bounds of pi by drawing a regular hexagon inside and outside of a circle, and successively doubling the number of sides until he reached a 96-sided regular polygon. Any more sides and the universe implodes. Oh God, help me! By calculating the perimeters of these polygons and then dividing that number by the diameter of the circle, he proved that 223 divided by 71 is less than pi is less than 22 over 7, or 3.1408 is less than pi is less than 3.1429. This was a method of solving for pi that is accurate up to 2 decimal places. Both the upper bound and lower bound numbers contain 3.14.
So, hope you enjoyed those videos. So we're going to have 2 competitions for PSHE house competitions. The first one is a competition to memorize and recite pi to the most decimal places. Mr. Vitali will judge that. He will give you opportunity to recite pi, and whoever does it to the most decimal places will be the winner. And of course, whoever does it the next best will come second, and so on. And also there's a competition to draw a freehand circle. Now, there are different ways of doing it, and some of them may be considered to be a hack or maybe cheating. Mr. Vitali will set the rules. He'll tell you exactly what you're allowed to do in order to draw the freehand circle, and he will judge the most accurate. And again, the most accurate is the winner. The next most accurate comes second, and so on and so forth. So I wish you a lot of luck with that. It should just be a little bit of fun, not too taxing, shouldn't take you a lot of time, and something you can do in the context of your maths classes. And what you can be doing now in PSHE is you can be practicing. So you can be practicing your freehand circle drawing and practicing your memorization skills by learning pi to as many decimal places as you can. So good luck, enjoy.
I am Leonardo Perez Nieto, and today I will show you 3 ways to draw a perfect circle. Actually, 2 of them are hacks, but they are very effective. And the third one, it is a true artistic technique to draw a circle freehand. This is the first trick. If you want a small circle, place your middle finger by the lead and then firmly on the paper. Then smoothly turn the paper around. It will be turning around your finger, which is the axis. And hold your hand and the pencil very still. And we have a small circle. If you want a slightly bigger circle, use 2 fingers, like this. Good. For a still larger one, use 3 fingers and place the pinky down. Like so. Good. And for a bigger one, use this bone of the wrist. Put it down firmly, but not with a lot of pressure, because otherwise it is hard to turn the paper. The whole hand and the wrist are locked, not moving. And apply a constant pressure with the pencil. Ta-da! Let's do this again, but this time using a fine marker. We place the hand very firmly, standing on the bone. And I begin moving the paper before putting the tip down, so that it is smooth and I don't get a mark. There you go. Let's do another version of this with two pencils. They can be of different sizes. We arrange the tips so they are level, place one firmly on the paper, and draw with the other one. This is very precise. Okay, these tricks can be very useful, but now let's go to a real artistic technique. We hold the pencil more perpendicular to the paper than usual and smoothly start making circles. Move the whole arm from the shoulder. Good! And now if you want to, you can go over a single line in this fashion. I rotate the paper to keep this position because the other side of the circle is more complicated. This side is more natural. If you are left-handed, it would be the opposite, of course. Very good. Okay, let's do one more. Hold the pencil perpendicular to the paper, and I usually make a couple of circle movements without touching the paper. Then I start lightly and at an even pace. Remember, practically all the movement will come from your shoulder and whole arm, and the elbow will move just a little bit. I made so many lines that one must be correct. So we go over it. Visualize the circle you want to make and go over it. Like so. You could leave it like that depending on what do you need it for or how you want it to look, or you can clean it up. In this case, erase all the lines that shouldn't be there, both outside and inside the circle. Alright, we have a circle. This of course requires some practice. One good exercise that you can do is to trace a circle using an object with a marker and then go over the line with your pencil. Over and over and over and over. I usually go over it without touching the paper for 2 or 3 circles, and once I feel I have the hang of it more or less, then I start pressing lightly. Do this with circles of different sizes and you will become proficient at it.
So now's the time to get practicing. Start drawing those circles freehand and start memorizing pi to as many decimal places as you possibly can. Not quite sure you managed the full 1,000 that are listed here, but you can give it a go. Now, on another note, let's remind you about the charity event which is being organised by our student council, and particularly Rania, Miriam, Ashme and Celine. You've been asked to bring in goods for the less fortunate people in our society. So you can bring in food and of course cans, dry food, anything which isn't perishable. You can bring in toys, of course in good condition, that can go to children in our community. Clothing, again, good condition, washed, nicely folded. Any furniture that your parents may wish to donate, or any other donations which can go to help people. And the dates started on the 9th of March, continuing up until the end of the month, almost on the 28th of March. So please make sure that you bring in as much as you can to one of the students who were listed, and Mr. Marder, who is assisting them particularly. You see that there's already the table and reception and lots of goods already building up. So very good work to those of you who've already contributed. Thank you. Please keep the donations coming. And we truly hope that you'll be all part of this to help adults and children in our society, to help the association who we are going to donate all of the goods to. And we're counting on each one of us to be part of this, so please do the best you can. And again, thanks so much to the 4 students who are spearheading the initiative, but also to the entire student council who are supporting it. It's wonderful work, and keep it up. Thank you.